Well, good afternoon, everyone. I couldn't turn up the audio input. I looked on the control manager, so I'm going to just try to talk louder. I'll be the ugly American. This is 11-1 examples. A couple of people said to me today, what is the difference between a rectangular coordinate and a polar coordinate? And really, it's just a different form. It's like one language is Spanish and one language is English, and it's the same word, just in two different languages. So let's work some examples of those. Generally, a picture is a good way to start. Number one, how about rectangular coordinate 0, -2? Well, draw a little picture. You start at the origin. 0, -2 means you just go straight down 2 units. And you get there. This one's pretty straightforward. If you think about 0 degrees being over here, now we're back to the math definition of an angle, which goes like that counterclockwise. How far is that? 270 degrees. So, and of course the distance is now just 2. It's not -2 or +2, it's just 2. That is one difference. So 0, -2 then would be the same as R2, comma, 270 degrees. I better put a degree sign on there. Or an alternate version would be 2, comma, -90 degrees. Or of course you could do it in radians as well. Let's try another one. Number 2, example. How about one with a radical? I know you all love radicals. 6 times the square root of 3, -6. Another rectangular coordinate. We're familiar with those. Again, draw a picture. And it is just a little sketch is all you need. Okay, starting at the origin, if you go out your x coordinate, 6 times the square root of 3, that's about 10-ish. And then -6, so it wouldn't be quite as long. Look like that. So again, think Pythagorean theorem. This is the length of one leg. This is the length of another leg. Because it's on the x and y coordinate plane, we know they form a right angle, so we can use Pythagorean theorem. So here we go. 6 times the square root of 3 squared plus -6. And your calculator will lie to you. You may want to use parentheses. If you just put in -6 squared on a TI calculator, it'll tell you -36. Don't believe it. Equals r squared. Okay? Now, this is one place where knowing how to deal with radicals is really, really helpful. If you have 6 times the square root of 3, you just square both components. So now we have 36 times square root of 3 times the square root of 3. No calculator needed there. 3 plus -6 times -6 is 36 equals r squared. 36 times 3. 36 times 3 is 108 plus 36 equals r squared. 144 equals r squared. So r equals plus and minus 12. Can't resist. In this case, it's positive because it's a distance. So then our final coordinates we could find. We know that r equals 12. And now we can use inverse sine, inverse cosine, inverse tangent, take your pick, to find our angle theta. So I think you all can do that part. Keep in mind the actual theta would be like this, and this would be the opposite of theta if you go that direction. And that's fine too. Okay, one last example. I don't want to talk for a long time today because I know you're busy. Number 3. What would be a good one? How about negative 512? So again, make a little sketch. I'm going to shorten this one up just a little bit. Negative 512, I already know the distance there. That's an easy one. The only difference here is we know that this is in quadrant 3. So once again, negative 5 squared, use parentheses, plus 12 squared equals r squared. And that is going to come out to be 169 equals r squared. And square root of that is 13. I knew that already because it's a 5, 12, 13 triangle. It's a Pythagorean triple. So r equals plus and minus 13. And this one maybe I'll actually do it to find the angle because this one's a little bit different. So let's say our theta is right here. So now we are going to have, I would just start with the opposite and adjacent, so tangent. So we can say tangent theta equals 12 over negative 5. Tangent theta equals 12 over negative 5. So check that out right now. Theta then equals arctan of 12 over negative 5. Everybody try that for a minute. You may want to pause the video at this point. So when you did that, you got theta equals negative 67.38 degrees. And you got negative because the 5 is a negative here. If this had been in quadrant 1, it would have come out to be positive. So don't let the negative freak you out. Just be aware that because you're in quadrant 3, it's going to read this theta as 67.4 degrees, was it? I can't remember. 4 degrees. That part I'm not as crucial about. And then in order to get the actual angle for the coordinates, you have to remember that we are starting here, wrapping the angle all the way around like that. So that looks like we're adding 180 degrees to our theta. So for now, you're going to have to ignore the sign, and that, it takes a little doing sometimes. So we're going that our angle, and maybe I should have used something else instead of theta. I'll use a different one. I'll say alpha equals theta plus 180 degrees. So alpha equals 67.38 plus 180. So alpha equals, you grab your calculator, check. You guessed it, alpha equals 247.38 degrees, or 0.4. I guess we got everything in terms of, yeah, that should be fine. So alpha equals that, and then our final polar coordinates. R theta, in this case R alpha, would be radius of 13, comma, 247.38 degrees. Make sure you're in degree mode or radian mode. If you give it in radians, just make sure you're in radian mode. Now, finally, and I always encourage you to say, does my answer make sense? Well, this angle has to be between 180 and 270. So an angle of 247, I believe, is very reasonable. Okay, let's see. We're almost 10 minutes in, so I think that's enough for today. Work through a few more of these examples until you're comfortable with rectangular to polar coordinate conversions. Thanks, and have a good night.